Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guided notes called the Distributive Property. Alright, let's first explain what the Distributive Property is in words. When you have an addition or subtraction problem, which will usually be written in parentheses, being multiplied by a number, you can multiply each term of the addition or subtraction problem of the sum or difference by the multiplier. Now, symbolically, using algebra, here's what this looks like. You're going to have either addition or subtraction inside of parentheses. And what you can do is you can take the multiplier that is sitting outside. When you have a number right next to parentheses, nothing in between, that means multiplication. You'll take the multiplier on the outside and you'll multiply it to not just the first term, but also to the second term. Same thing here. That's what the distributive property is. Now, if that still doesn't make sense to you, I have four examples already done for you. Let's take a look at these right now. Problem number one. Do you see who the multiplier is? Well, I already have it labeled for you, but the number that is sitting outside of parentheses, right next to the parentheses with nothing in between, that is the multiplier. We're going to multiply that to not just the 6n, but we're also going to multiply it to the other term inside of the parentheses, which was the 11. 5 times 6n, 30n. 5 times 11, 55. Now, the multiplier is not always going to be on the left side. Sometimes the multiplier can be on the right side, so make sure you're looking for that on possible problems. 3 times 9 and 3 times the 12x. Notice this time there is subtraction in between, so that's why I keep the subtraction in between here. So I will take 3 times 9, 27. 3 times 12x. Now, in my head, I kind of switch the order here, and I do the 12 times the 3, which gives me 36, and then I leave the x to the right of it. So I'm kind of doing commutative property in my head, 3 times 12, then times x, and that's going to give you 36x minus 27. If you're wondering if you could simplify these even further, like could you make the number 1 become 85n? No. Could you make 36x minus 27 become 9x? No. Does not work that way. Now, if I knew the value of n or the value of x, then I could substitute it in and actually go further. But without knowing the numbers that those variables equal, there is no way to go any further. Problem number 3. This one is unique because even though there's a multiplier on the outside, which is not unique, there is 3 terms. So the multiplier goes to all 3 of them. Not that big of a deal. And I did throw a negative here. In your calculator, if you don't know what 14 times negative 3 is, you don't type in the x. Don't even look for an x key or a y key or a z key. It's not on your calculator. You're just going to multiply the numerical parts, the 14 times the negative 3, to get negative 42. That's what you type in your calculator. The x you just write with your pencil on the paper next to the result that you got from your calculator. So please don't look for x, y, or z in your calculator. It's not there. So, not a big deal, number 3. It gets multiplied to each of these terms, and we do each of them, and we get our results, and there you go. And finally, number 4. Notice there is a fraction to the outside of the parentheses. So the entire fraction is the multiplier. Now, good news. We have a fraction key in our calculator, and yes, you're allowed to use it. So in your calculator, you would take 5/6 times 24, and that would give you 20. Obviously, you're keeping the x here on your paper. You would then take 5/6 times 6 in your calculator, and that would give you 5. Notice this problem, kind of like number 2, had minus in between, so you got to keep that minus. And obviously, don't lose the x. All right, now that I've gone through the 4 examples that I've typed up for you, go ahead and use those examples as kind of a guide to then take you through numbers 5, 6, 7, and 8 on your own using the distributive property. So hit pause now, do those 4 problems on your own, and then hit play when you're ready to see how you did. All right, did you already do 5, 6, 7, and 8? If not, you got to hit pause now and do them. Here we go. We're going to take that distributor, that multiplier, and distribute it to both terms. We're going to take 11 times negative 7c and 11 times 15. What do we have in between? We have addition. 11 times negative 7c is negative 77c, and 11 times 15 is 165. Problem number 6. There are 3 terms on the inside, so we're going to take 8 times h, 8 times 9w, and 8 times 20. And we're going to keep the addition in between here and the subtraction in between here. Let's go ahead and multiply. 8 times h is 8h. Bring down the plus. 8 times 9w is 72w. Bring down the minus. 8 times 20 is 160. Problem number 7. The multiplier was the 3/8, and it's on the right-hand side. We're going to distribute that to both terms on the inside. So we're going to take 64 times 3/8, and we're going to take 48x times 3/8. We'll keep the minus in between. Using your calculator, 64 times 3/8 is 24, and 48 times 3/8 is 18. Keep the x there, bring down the minus, and there you go. Now, in case you're wondering, there is a way you can do this without a calculator. If the number that you're going to multiply to is divisible by the denominator, then you can actually take that number, divide by the denominator, and then take that answer times the numerator. Let me show you. 48 divided by 8 is 6. 6 times 3 is, 18. It does work over here. Well, is 64 divisible by 8? Yes, it is. 64 divided by 8 is 8. Times 3 is, 24. So if the number you're multiplying the fraction to, if that number is divisible by the denominator, then there is a shortcut trick where you could divide by the denominator and take that answer times the numerator. Then you wouldn't need a calculator for those. All right, problem number 8. Like number 7, the multiplier is on the outside on the right. So we're going to take 3 times 18m, 3 times negative 31k. There's an addition sign in between. This is going to give you negative 93k and 54m. All right. What if the multiplier is a negative number? Okay, remember, subtraction is the same as adding the opposite. So 4x minus 7 is the same as 4x plus negative 7, because subtracting by 7 is the same as adding by negative 7. We learned about this in the previous unit. 33y minus negative 18 is the same as 33y plus positive 18, because subtracting by a negative is the same as adding by a positive. Why am I going over this? Well, because you're going to use this concept, that subtraction is the same as adding the opposite. You're going to use that for 2 scenarios, both of which involve having a negative number as the multiplier in the distributive property. Let me show you what I mean. Take a look at the bottom. Here's the first scenario we're going to look at. We're going to make sure our final answer is in simplest form. Okay, so take a look at this. We got negative 8 on the outside, so we're going to distribute negative 8 to the 4p and negative 8 to the 7. Not a big deal. Negative 8 times 4 is negative 32. Bring down the p, bring down the plus. Negative 8 times 7 is negative 56. So far, really not that big of a deal. But here's what you need to know. Having a negative sign to the right of addition is not considered simplest form. So this right here is an issue. And high school math teachers are going to be very picky about this. That is not considered simplest form right there, plus negative. There's a simpler way of writing that, and it's actually just subtracting a positive. Now, you're like, what? Subtraction is the same as adding the opposite. So subtracting by 56 is the same as adding by negative 56, but we're doing it backwards so we could get an answer that looks just a little bit simpler. Instead of having 2 symbols here, plus and negative, it's just 1 symbol, and that is minus, and then you have the regular positive 56. So yes, you actually have to do this if you have plus negative, or even if you would have minus negative, you would have to make that adding the opposite, which is adding a positive. So that's something you're going to have to keep in mind if you have a negative number to the right of your plus or to the right of your minus. That is making it become simplest form when you make it become minus 56. Now, here's another scenario to think about. When there's subtraction inside of the parentheses and you have a negative multiplier, what do? Well, you got 2 options. You can either make subtraction become adding the opposite at the end, or you can make subtraction become adding the opposite at the very beginning. I personally don't care which way you do it. If you do it at the end, here's what it's going to look like. This subtraction will stay subtraction in between, and you're going to take the multiplier, you're going to multiply it to both of these terms. Not a big deal. That'll give you negative 60m and negative 12, but the minus is still in between. And right here, this is not simplest form because it's two symbols instead of just one. So instead of having minus and negative, we're going to say subtraction is the same as adding the opposite. And the opposite of a negative is a positive. That's one way of doing it. Option 2, you can make the subtraction in between become adding the opposite right away. So as soon as you see minus 2, you can go boom, boom, adding the opposite, slash, slash, adding the opposite, and then you can go ahead and distribute the negative 6 to both parts. So negative 6 times 10m, negative 60m. Negative 6 times negative 2, positive 12. Now, some kids don't like that because they think there's too many negative signs here to keep track of. However, if you do it the other way, there's a minus to keep track of in between. So I really don't think one way is easier than the other. They're both about the same to me. Before we move on, one thing I want to say. If you have plus a positive, do not do what we did over here. Over here on the left of your page, when it was plus negative, we made this minus a positive because that looked simpler. I got news for you. If you have plus a positive, there's no way to make that look simpler. Do not go backwards and make it minus a negative. Do not do that. That does not look simpler. If it's plus a positive, then it's already good to go, already considered simplest form. Okay, I want you to use what we just looked at, both of these scenarios, use them as guides to do numbers 9, 10, 11, and 12 on your own. So hit pause now. Do 9, 10, 11, and 12. Again, use the bottom that we were just looking at the previous page to assist you in guiding you through these problems. Hit pause now, 9, 10, 11, and 12, then hit play when you're ready to see how you did. Okay, did you already do 9, 10, and 11, and 12? If not, you better hit pause now. We got the negative number as the multiplier. We're going to distribute it to both the 4m and to the 8. Please check your work. Keep the plus sign in between. Negative 15 times 4m is negative 60m. Bring down the plus. Negative 15 times 8 is negative 120. Before I go any further, double check that you didn't lose any negatives there. This is what you should have. However, having two symbols here in between is not considered simplest form. So we're going to use the idea that subtraction is the same as adding the opposite, and we're going to do it backwards. So instead of having negative 60m plus negative 120, we're going to say that's the same as minus regular 120, and that is the simpler way of writing that answer. Problem number 10. The multiplier is negative 24. Now I'm going to show you first how you would do it if you make subtraction adding the opposite inside first. Now, if you don't like that, I will show you the other way, where you make subtraction become adding the opposite at the very end. So I will be showing that here very soon. But for those of you who did it first, here's what your work's going to look like. Negative 24 times 2a and negative 24 times negative 3d. Yes, that's a lot of negatives here. The plus would stay in between if you made this adding the opposite right away. If you didn't, then there would be a minus in between. We'll get to that soon. Negative 24 times 2a is negative 48a. Negative 24 times negative 3d is positive 72d. For those of you who made subtraction adding the opposite later, here's what your work is going to look like. You're going to have minus a negative, and then you're going to make that become slash slash, adding the opposite, and then it's now looking like the same as you had up there. Either way is fine with me. Problem number 11. Who is the multiplier? Well, this one's unique. We have a negative multiplier on the right side. When you have parentheses next to other parentheses with nothing in between, that means multiplication. So the negative 2 is the multiplier. Let's distribute it to the 5y. Oh, it would be negative 5y if you added the opposite right away. If not, then it would have been a positive 5y, but then 5y, but then you would have had the minus in between. So going back to the way where you make it out in the opposite first, here's what your work will look like. Both parts get times by negative 2. A negative times a negative is a positive. And same thing here. A negative times a negative is a positive. For those of you who did not make subtraction out in the opposite first, you're still going to get positive 32. But you're going to have a minus a negative 10y, because positive 5 times negative 2 is negative 10. But then you're not going to leave it like this. You're going to make it become slash slash, adding the opposite. And now you have the same answer as the kids who did it the other way. Problem number 12. The multiplier is negative 2/9. We're going to distribute that to both the 3x and to the 36. Keep the plus sign in between. Negative 2/9 times 3 is still a fraction. Negative 2/3 x plus, this one you can do without a calculator. 36 divided by 9 is 4, times negative 2 is negative 8. Oh, but before you circle that, do you see what I see? We have two symbols in between, not considered simplest form. So we're going to use the fact that subtraction is the same as that in the opposite, but we're going to do it backwards. And that's going to make a negative 2/3 x minus 8 instead of saying plus negative 8. Okay, last thing we're going to look at are some real-life scenarios where the distributive property can actually be used. Follow along with me. Kyle buys 3 soft pretzels for X dollars each and 3 sodas for $1.29 each. Write a simplified algebraic expression to represent the total amount. Ladies and gentlemen, underline or highlight this. Total amount is where you add things together. However, we're buying 3 soft pretzels and 3 sodas. So we have a common multiplier of 3, and it's going to get distributed to the X and to the $1.29, just like you were seeing on the previous page. 3 times X is 3X. 3 times $1.29, use your calculator, $3.84. And there is your expression, simplify, like we were told to, simplified, that represents the total amount. Now, if I just went through that way too fast, go to the think box. To get total amounts, you would add the price. That's right, fill in that blank. Add the price of the pretzels to the price of the soda. That's what I had here in the parentheses. It's just that the price of the pretzels was unknown. It was called X dollars. You can't really add X to $1.29 without knowing what X is. So you're going to put a plus sign in between, but you can't really add them. Since Kyle is buying 3 of each, you would multiply the 3 to the sum, and that's exactly what we did. So go ahead and fill in that blank if you didn't do so already. Now, note, each problem is unique. Please do not think that every problem below is going to be the same as number 13. It might not be exactly the same. For example, spoiler alert, it's possible for something in real life to mean subtraction and not addition. Yes, finding a total amount is addition, but there are some things in life that might mean subtraction. Am I possibly spoiling a future problem? Perhaps I am. I'm not going to tell you which one. You're going to try number 14 and number 15 on your own, and then you'll hit play when you're ready to see how you did. So go ahead and hit pause now and do 14 and 15. All right, did you already do 14 and 15? If not, you better hit pause and do it now, because here we go. $17 per hour, but she's working 6 hours on Friday and N hours on Saturday. We know per hour means times the hours, but we have 2 different amounts of hours. So what you would do normally in real life is you would add the 2 amounts of hours and then multiply by 17. Well, the hours on Saturday is N. So yes, I will put plus here, but I can't really do 6 plus N without knowing the value of N. But I can put the multiplier of 17 on the outside and then use the distributive property. 17 times 6, 17 times N. That's going to give me 102 and 17N. Well, the order is backwards, but not a big deal. Commutative property says you could switch the order here within the addition and have 17N on the left and 102 on the right. So, ding, 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 choice B is the correct answer. And problem number 15. Jeremy or Jerome, however we pronounce this word, buys 12 flowers, each for D dollars. So normally you would think you would just take 12 times D. But wait, there's more. He has a coupon that is $2 off. Keyword off. Off means taken away, subtracting. From what? The price of each flower. Well, the price of each flower was D dollars. So in parentheses, to make sure it would get done first in real life, you would take the D dollars and subtract by 2. Now, obviously, I can't really do that without knowing the value of D. But the reason that's in parentheses is because in real life, you would take the price, $2 off of the price of the flower, before you would multiply it by 12. That's why we need the parentheses. Now, distributive property. 12 times D, 12 times 2, keep the minus in between. You would get 12D minus 24, and ding, 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 that is choice D. All right, and that finishes the guided notes on the distributive property. Thank you for watching. We'll see you next time.